Hi, everybody. So we're going to talk about section 5.1. Okay, I know that this is out of order from what the traditional book does, where you just go, chapter 1, chapter 2, but we're going to do a couple of sections from chapter 5. The homework from this section is going to be from Canvas. It's the modeling functions and graphs section 1.2. Okay, so let's get started. The first thing we're going to look at is a definition. Okay, we're going to define what a relation is. Okay, so a relation is any set of ordered pairs. There's no rules about what pairs are allowed. Okay, any set of ordered pairs at all. Okay, you could organize them in a table, you could express them as a graph, anything like that. Okay, so I'll just give you a little example. So we could have a relation that has two ordered pairs, just 0, 1, and then 2, 2. Okay, this is an example. It's a set of ordered pairs. Okay. Let's look at the parts of these ordered pairs. Okay, so the first coordinate is called the independent variable. We would normally associate this with x. Although it doesn't have to be x. Okay, and this is the input. Okay, so the way of talking about independent versus dependent variables is something that they talk a lot more about in science. So because you guys are mostly scientists, it's important to remember that there's a reason it's called independent, right? This is something that just happens. It's not dependent on anything else, whereas the dependent variable should rely on this, right? Good examples of independent variables are usually time or that kind of thing where it's just happening whether or not anything else is happening. And then the dependent variable in a science experiment is normally the measured value, and it's what you're keeping track of. Okay, so that's actually the next definition, is the dependent variable. Okay, we normally associate this with y. Okay, and also this is the output. Okay. All right, so there's the parts of a relation. We have the first coordinate, which is the independent variable, that's the input, and the second coordinate, which is the output, that's the y variable called the dependent variable. Okay, so now let's talk about what a function is. Okay. So this is why we talked about relations, because a function is a special type of relation. Okay, so the only rule that makes something a function is we want each input value, right, or each x value to have exactly one output value or y value. Okay, so this condition has to do with x values, and you are checking each of the x's to see what y's go with them. Okay, so to see kind of how that would look, let's look at an example. Okay, so we're first going to look at a couple of tables and we want to see if they represent a function. Okay. All right. So we're going to check using the definition, right? And remember the definition is that for each x, there is exactly one y. So because there's only, 4 x values, we're just going to check every single one. Okay? So for this x2, we're checking, is there an associated y value? Yes. Here it is. And is there just one y value? Yes, it's just one. Okay? Then we'll do the same thing for 3. Is there an associated y value? Yes, here it is. Is there only one associated y value? Yes. Okay. Here, is there an associated y value? Yes. Is there only one associated y value? Yes, it's just 2. Okay. For this value of x5, is there an associated y value? Yes. Is there more than one? No, it's just the value 0. Okay, so we would say, yes, this is a function. Okay, and that's how you check for a table of values. Okay. So let's look at some other examples using tables. Okay, so right now, okay, I want you guys to look over these and maybe pause the video and decide what you think. Do you think these are a function? So yes, it is a function, or no, it is not a function. Okay, so go ahead and check what you think for yourself before you listen to me explain why it is or isn't a function. Okay? Okay, so we're going to check like we did in part A. We're going to look at each value of x. We're going to check that it has a corresponding y value, and we're going to check that there's only one corresponding y value. Okay, so for the x value 2, we can see that it does have a corresponding y value. Okay, but there's something happening here, right? You have this x value 2. It has another corresponding y value. So you can see that this single x value 2 has 2 different corresponding y values, right? 4 and 2, okay? This is against the rules for a function, right? A function is a rule that takes one x value and assigns one y value, okay? So we don't want this. This is not a function, okay? And the circled ones are why not. You can't have one x, okay, has 2 y values, 2 and 4. Okay, so that's the issue of why this isn't a function. Okay, so let's look at the other one. We're going to start with the x value 2. We're going to check that it has a corresponding y value, 0. Does it have more than one corresponding y value? No. Okay, so that one's good. What about 3? Does that have a corresponding y? Yes. Is there more than one corresponding y? No. 4 has a corresponding y. There's only one value for 4. 5 has a corresponding value 0. There's not more than one value for 5. Okay, so that means yes, this is a function. Okay, don't let it confuse you that the y value 0 has a bunch of x values that go with it. That doesn't matter. You are only checking the x values. Okay, you're checking for each x, is there a y? Is there only one, right? You don't want more than one like this situation, but it doesn't matter if all the y values are the same, if they're all different, if they repeat. That's not important in whether something's a function or not. Okay. All right. So let's ask the same question. Is this a function? But let's look at a different way to describe a function. Okay, we're going to look at a diagram. Okay. Okay, now these little diagrams are just to describe input and output values. We know that they usually represent numbers. Okay, so these are my input values here on the left, and these are my output values here on the right. Okay, now the arrows show what the function does for each input. So this function takes this here, this here, this here, and this here. Okay, so we want to know, is this a function? Okay, so we're going to look at each input dot. We're going to check that it has an output, and we're going to check that it only goes to one output, right? That it doesn't go to many outputs. So this input, it does have an output, and there's no more than one. This input does have an output, just one. This input has an output here, just one. This input has an output here, just one. Okay, so we would say, yes, this is a function. This is a perfect example of a function. Okay, now again, this is kind of the same issue that we saw in part C, where we have a repeated output value, right? Both of these inputs go here, not important, not an issue for a function, okay? All right, let's look at another diagram. Okay. Let's look at this. We don't really need this output value. That's not there. Okay. So we're going to check each input value, and we're going to see if it has one input, goes to one output, or more than one output, or no output at all. Okay, so we're looking at this input. Does it have an output value? Yes, here it is. Is there more than one? No, it's just this one. Okay, look here. Does it have an output value? Yes. Is there more than one? No, just this guy. Look here. Does it have an output value? Yes. But it has two output values. This input goes both here and here. Okay, this is our issue. So this is no. Okay, the third input has two outputs. That's why this is not a function. Okay, let's look at another example. Okay, decide what you think now. Is this a function or not? Okay, so if we look at this, we're going to check again each input. Does it have an output? Is there more than one? Okay, so when we look at this very first input value, is there an output value associated with that? No, because there's nowhere for this dot to go. So right away, we can say that this is no. The first input has no output. Okay, that means it's not a function. Okay, now this is something that's really hard to represent in another form of a function, so that's why these diagrams are kind of nice. You can kind of see all the different possibilities. Okay, let's look at one more of these diagrams. Okay, so decide for yourself now if you think this is a function or not. Okay. All right, if you look at this, we're going to check the inputs. It's really important to remember that when you're talking about whether something is a function or not, you are checking each input. You're not checking the outputs at all, okay? So we're going to look at this input value. Is there associated output? Yes. Is there more than one? No. Here, is there an output? Yes. Is there more than one? No. Is there an output value? Yes. Is there more than one? No. Okay, so we would say yes, this is a function. And you might say, but what about this? There's nothing that lands here. Not an issue for a function. Okay, it is kind of weird, seems unusual, but that's not keeping it from being a function. Okay. All right. Let's move on to equations that represent functions. Okay. So we're going to start by looking at what is called function notation. Okay. If you're working on the homework and you're looking for the part of the video that has to do with graphs of functions, that's in the next section. It's not in this video at all, so I would do that one if that's what you're looking for. Okay. Here we're going to talk about what makes something a function, which we just did, and now we're going to talk about function notation. Okay, so function notation looks like this. Okay, and you would say this out loud as f of x. Okay, x is the input. Okay, it's the independent variable. It is inside the function, right? Okay, the whole thing, f of x, is the output. Okay, the dependent variable. Okay. You might be saying, okay, if x is the independent variable and f of x is the dependent variable, then what is f? Okay, f is just the name of that function. Okay, it's neither. It's not the input, it's not the output, it's just the name of the function. Functions have different names. This one is named f. Okay, other common names for functions, g, h, and then variables that represent what you're talking about. C for cost, h is usually for height, that kind of thing. Okay. All right. So, I just wanted to point out, even though we sometimes use parentheses to represent multiplication, this has absolutely nothing to do with multiplication. Okay, just putting that out there. Totally separate notation, totally unrelated. Okay, so let's look at how we can represent or how we can use this function notation. Okay. Okay. So we have f of x is 3x minus 5. Okay. So we're going to do a couple of things with this function. Okay. Okay. So the first thing we're going to do is find f of 0. Okay. So we are going to, you can see that the 0 is here where the x would normally be. Okay. And what this is telling you is that you are inputting 0 for x. Okay. They want you to evaluate, right, or plug in the function with x equals 0. So that's exactly what we're going to do. Okay, and then we're just going to simplify it to a single numerical answer. 3 times 0 is 0, minus 5 is negative 5. Okay. Now, it is important that you show both of these steps. If you are doing this problem for homework, you're doing it for a quiz, you absolutely need to show both of these, and here's why. This one shows me that you understand function notation, and this one shows me that you understand you're supposed to simplify your answer. Okay, so because they show two different things, you really need to do them separately. Okay, if anything, the first one is more important because that's what we're learning now in this class is how do we use this function notation. Okay, so let's look at part B. Okay, and I want you guys to do this now. Remember, f of x was 3x minus 5. Okay, so for yourself in your notes, right now just pause the video and go ahead and find f of 2. Okay, remember that's how you would say this, f of 2. Okay, so 2 is our input value, that's our x value. So we're going to input 2 into our function here for x. Oops, that is not an equal sign, that's a minus sign. Okay, 3 times 2 is 6, minus 5 is 1. Okay, so this is how our answer would look. First step to show that we understand what we're being asked with function notation, we know how to use function notation. Second, shows that we understand what the format of the answer should be, f of 2 equals, and a single numerical value that is the output. Okay. All right. So we're going to answer a couple more questions about that same function. So I'm just going to remind us f of x is 3x minus 5. Okay. And we are going to find all values of x so that f of x is 1. Okay, now you can see right here what they're asking you to do. Okay, so we're going to take our original function and we're going to plug in 1 for f of x. Okay, so we're replacing the whole expression f of x with the value 1. Okay, and then we are finding x. Okay, so we know from last time that that means our answer should look like x equals a number. So that's what we're going to do here. And my answer would be x equals 2. Okay. So remember, f of x equals 1 is telling you to plug in 1 here. Okay. And then find x is telling you that your answer should have the format x equals a number. Okay, let's do one more of those. Okay, so right now you should pause the video, do this one for yourself. It is much like part C. Go ahead and do that now. Okay, so we're going to start by substituting 0 for f of x. So that would give us 0 equals 3x minus 5. Okay, and then remember we're finding x. So here we're going to solve for x. Okay, so my answer is going to look like this. X equals 5/3. Okay, the steps that you absolutely cannot leave out. This first step that shows me you understand what you're being asked to do and you understand function notation. This step that shows me you understand what the format of the answer should be and that you got the correct answer. Okay. You should leave it as a fraction like this. You shouldn't put it as a decimal. You probably won't have a calculator, and in any case, this is a good exact answer, where if you put, 1.66, that's not an exact answer. Okay, let's do one more example of using function notation. Okay, so in this example, we have two different functions, f and g. Okay, at this time, I'd like you to pause the video and answer these two questions for yourself. Okay, so what we would do, we're going to find f of 0. Remember, this 0 is an x value. It's inside, it's the input. Okay, so f of 0 is, and then we're going to plug in 0 for all the values of x here. Okay, so we're showing ourselves inputting that 0. That's super important. And then we are going to give our answer. 0 squared is 0, times 2 is 0, 3 times 0 is 0. So this is going to be 0. Okay, so remember both of these steps have to be shown. This shows that you understand the question and you understand function notation. This is showing me that you understand the format your answer should look like. F of 0 equals, and then your answer. Okay, we're going to do the same thing here. G of 0 is 5 minus 6 times 0. Okay. 6 times 0 is 0, so this is just going to be 5. Okay. Those are very similar to what we did in example 3 in part A and B. I just wanted to do an example to show you, okay, you can still do that even with two functions. Okay. Again, these are very similar to the questions in part 3, in example 3. This is like part C and D, okay? So go ahead, pause now, and do these for yourself, okay? So we're going to substitute in the first one 0 for g of x, okay? So remember, these are what our functions look like. Okay, so we're going to substitute g of x for 0. Okay, and then since it says find x, we're going to isolate x. Okay, again, this is the only step you could potentially leave out from this. You absolutely need to show this one, and you absolutely need to show your answer. Okay, we're going to leave our answer in fraction form again, and I will encourage you to do that throughout the class. Okay, all right, let's look at part D. So I'm going to substitute 0 for f of x. Remember, this is what f of x is. Okay, so I'll have 0. Okay, now remember what you do when you have x squared type of equations. This is going to ask you to recall some of your information from Algebra 1. Okay, so when you have an x squared type of equation, you usually try to solve by factoring, and you'll notice that these have a common factor of x. So I'm going to factor out x. Okay, and now I'm going to continue my solving process by setting each factor equal to x. Okay, so here I already have my solution, x equals, and over here I'm going to finish this by subtracting 3 from both sides and then dividing both sides by 2. Okay, so here I'm actually getting two different solutions for x. X equals 0 and x equals -3/2. Okay, that is totally fine, and oftentimes if your function isn't this type of function, right, a linear type of function, you will get more than one solution. Okay, there's nothing wrong with that, and that's actually why the question says find all values of x. Okay, all right, let's do the very last part of this question. Okay, so we are meant to find all values so that f of x is equal to g of x. Okay, so remember, these are our values of x and g of x. Okay, if we want them to be equal, okay, we're going to put in the expressions for those. So f of x was 2x squared plus 3x, and g of x was 5 minus 6x. Okay, now we're going to solve this equation. Again, it's an x squared type of equation, so we're going to try to solve it by factoring. Okay, so I'm going to move everything to the left side here, add 6x, subtract 5. Okay, and again, I'm going to solve this by factoring. Okay. (10 minus 1 is 9. Okay, so I know my factoring works. And I'm going to set each of my factors equal to 0. And then I'm going to finish solving these two equations. Okay, so there's my two solutions. X is 1/2 and x is -5. Okay, again, you're allowed to have more than one value for x. That's why it says find all values. Okay, all right. I'm going to do another short video on this section that has to do with application problems, so I will see you guys soon.